What is meant by following terms? Give a reaction in each case. I'll consider one by one. First one is cyanohydrin. Cyanohydrin, actually these are the compounds which have hydroxyl group and cyano group, that is nitrile group, on the same carbon. These are also called gem hydroxynitriles. Means gem means on the same carbon, geminal. Okay, we have hydroxy and nitrile groups. That's why these are obtained by HCN added to the carbonyl group. Okay? In weakly basic medium, means pH should be around 10. So this is the reaction, generic reaction. You have a carbonyl group here, you get it reacted with HCN. So what happens here? This bond breaks. Okay, so logically it becomes like this, CO, right? C, and like this. CN goes to one carbon, right? Like here. And because here you already have OH goes here. So you have cyanohydrin. If you see the actual example with acetaldehyde, if HCN is reacted at weakly basic medium, then you get OH and CN attached, you will get acetaldehyde cyanohydrin. The names of these cyanohydrins are on the basis of from which compound they have been produced. So for example, here this cyanohydrin has been produced from acetaldehyde. We will say it is acetaldehyde cyanohydrin. That is the naming convention here. What is meant by the following term, that is acetal here? Acetals are dialkoxy compounds. Alkoxy compounds are OR. Okay, so there will be something like this. For example, OCH3. Okay, like this. This is single alkoxy compound. If I say single, it will be OCH3. Two alkoxy groups are present on the terminal carbon atom. Means whatever is the terminal carbon atom, whether on left hand side or right hand side, we will have two alkoxy groups attached to that. These are produced by action of an aldehyde with two equivalents of a monohydric alcohol in presence of dry HCl. You can understand it with the examples. So if you see, this is aldehyde, ethanol, we have carbonyl group here. And remember what we are saying, these are produced by action of an aldehyde. Okay, so we have aldehyde here. And this one, if you see, we have monohydric alcohol, means there is only one OH group. We have taken two molecules, so that's why it is shown like this. This is ethanol. So what happens here? If you see H2O here, from here H2O is removed and rest of the bonds are connected, and you have two alkoxy groups on one carbon, and that carbon has to be at the terminal. In this case, yes, this carbon is on the terminal. Okay, this is the terminal carbon. Obviously it has to be, because this is aldehyde, and aldehyde groups are normally at the end. Semicarbazone, very important one. Semicarbazones are derivatives of aldehydes and ketones, which are obtained by action of semicarbazide on them in weakly acidic medium, used for identification and characterization of aldehydes and ketones. So this is very important method for identification of aldehyde and ketone. This is asked separately as well. Okay, semicarbazone, very important one. Here you have acetone, which is a ketone. You get it reacted with semicarbazide. Okay, so this is semicarbazide. It is amide group here, then we say it is semicarbazide. In acidic medium, pH is 3.5. Again, dehydration takes place. Rest of the bonds are interconnected. So what happens here? This H2O goes away. Dehydration. The rest of the bonds are connected, and we get semicarbazone. Aldol. Aldols are beta hydroxyldehyde or ketones. Okay, so at beta position we have hydroxy, so that's why beta hydroxy, produced by the condensation of two molecules of aldehydes or ketones containing alpha. Okay, alpha hydrogen atom means just near to the functional group. In the presence of dilute aqueous base, and this is important, whenever it is aldol, remember it will be dilute NaOH. We can use KOH as well, but most of the times you will see dilute NaOH. Why I am saying it is important to remember? Because it will give you a hint that it is aldol. If it is concentrated NaOH, it will be related to Canizaro. So dilute NaOH, aldol, concentrated NaOH, Canizaro. This is an example. You have aldehyde here and you have another aldehyde here. So what happens actually? You can understand it. This carbonyl group is polar. Okay. What happens here in this case, that the alpha carbon, this is the alpha carbon here. Okay. This will get attached to the carbonyl carbon, and one hydrogen on this alpha carbon, which is known as alpha hydrogen, will go to the oxygen. So actually what happens, this bond breaks, oxygen gets the electrons. When oxygen gets the electron, when this bond breaks, it becomes H plus, and obviously H plus attacks on this electron pair. So basically electron pairs will move to this hydrogen. In mechanism, whenever you show the mechanism, the movement is always of electrons. So here, although it is shown as hydrogen is attacking on this bond, the mechanism arrow will be from oxygen to the hydrogen, because it is movement of electrons. So that's how you get this compound, which is known as aldol. And you can see that here you have hydroxy group. Okay? And hydroxy group is on beta carbon. So remember, this is the CHO, this is alpha carbon, and this is beta carbon. So that's why these are known as beta hydroxy aldehydes or ketones. Another example, here we have ketone. Okay. This is ketone, and here we have another ketone. Okay, so those are both molecules of acetone. So what's happening here? One carbonyl group here on left hand side, right hand side we consider that one, normally that one, which has alpha carbon and alpha hydrogen. So this is the carbonyl group on second molecule. So this will be alpha carbon and it will have alpha hydrogens here, and we do see that there are 3 alpha hydrogens. So similar logic here, the bond will break, you will get electrons on the oxygen, this bond will break, this will become H plus. Here attack will be there on H plus. H plus will combine with oxygen, will produce OH. And this carbon, which is alpha carbon, will go to the carbon of the carbonyl group. It will get attached to the carbon of the carbonyl group. So you can see it is attached to the carbon of the carbonyl group. And we get aldol again. This is diacetone alcohol. And the reason is it is named like that because it has been obtained by 2 molecules of acetone. So if you see here, these 2 molecules are of acetone. So that's why the name here, diacetone alcohol, which is a type of aldol. Hemiacetal. Hemiacetals are gem alkoxy alcohols. Gem means, geminal means on the same carbon. Okay? Obtained by the addition of one molecule of monohydric alcohol to an aldehyde. Alcohol and aldehyde. The alcohol has to be monohydric, means there has to be only one OH in the presence of dry HCl gas. This is the reaction here. Example, you have aldehyde here, okay, and you have monohydric alcohol in presence of dry HCl. So what happens on the same carbon? As I said, geminal means on the same carbon you have both the groups. So what happens? You have both OH and CH3 on the same carbon. OH and OCH3, that is the alcoholic group and alkoxy group on the same carbon. That's why we call it gem alkoxy alcohol, which are commonly known as hemiacetal. Oxime. Oximes are formed when aldehydes or ketones react with hydroxyl amines in weakly acidic medium. This is the reaction. You have aldehyde here, you have hydroxylamine here. When they react, they produce oxime. This is known as acetal dioxime. Ketals. Gem dialkoxyalkanes. Again, geminal means on the same carbon you have dialkoxy type of alkanes. Two alkoxy groups, as I said, on the same carbon, that's why geminal, produced by reaction of ketone with ethylene glycol. Ketone with ethylene glycol. Just you need to remember, when we are talking about ketals, it is about ketones in the presence of dry HCl gas. So similar to the acetals, here also we have dry HCl gas. This is an example. We have acetone, the ketone here. We get it reacted with ethylene glycol. Ethylene glycol is on ethane. Both the carbons have one OH. Okay. So hydrogen is replaced. So you get CH2, CH2, one hydrogen is replaced by OH. This is ethylene glycol. So here this water is removed, dehydration takes place, and rest of the oxygens get attached to the carbon. So as you can see, you have two alkoxy groups on the same carbon. So that's why we are calling it dialkoxy. Imines. Imine compounds contain CH double bond N group. So this is identification. Remember, wherever you see this group, it means it is imine. Produced when aldehydes or ketones react with ammonia derivatives. This is the type of reaction. Remember here, Z can have multiple values. It can be NH, it can be OH, it can be NHC6H5, it can be NH, NHCO, NH2. Okay, so all these values are possible for this Z. So multiple reactions you can write using this generic one. So you have here carbonyl group. It can be aldehyde, it can be ketone. So imines are applicable for both, whether aldehyde or ketone. You get it reacted with ammonia derivatives. Ammonia derivatives means if you have ammonia NH3, you get one hydrogen replaced by something, that is Z, and Z can have different values here. 2,4-dinitrophenyl derivatives, 2,4-DNP derivatives. These are actually 2,4-dinitrophenyl hydrazones normally produced when aldehyde or ketone react with 2,4-dinitrophenyl hydrazine. Hydrazine. Which hydrazine? 2,4-dinitrophenyl. We have to produce 2,4-dinitrophenyl derivatives. So obviously we are using 2,4-dinitrophenyl hydrazine. In weakly acidic medium, this is the example here. You have here aldehyde or ketone. In this case, I have taken ketone here. And you get it reacted with 2,4-dinitrophenyl hydrazine. Okay. So here on second carbon and fourth carbon, you have nitro. So that's why 2,4-dinitrophenyl. And here you have hydrazine. Hydrazine is NH2, NH2. Okay. One hydrogen obviously replaced because it is connected with the benzene ring. So 2,4-dinitrophenyl hydrazine when reacted in acidic medium. Okay, in acidic medium, dehydration takes place. So what actually is happening here, if you see this dehydration taking place and CN bonds are joining. So these are 2,4-dinitrophenyl derivatives. We get here in this case acetone 2,4-dinitrophenyl hydrazone, and the name comes from the compounds being used here. So the compounds being used here, acetone is this one. Okay, this is acetone, and we have 2,4-dinitrophenyl hydrazine. So we combine and then we get it is acetone 2,4-dinitrophenyl hydrazone. Remember here it is zone, not zine. Schiff's base, also called as azomethine, another name, formed by reaction of aldehyde or ketone with primary aliphatic or aromatic amines. This is the reaction. Okay, so if you see here, this is the carbonyl group. I have taken aldehyde here. I get it reacted with primary amine. So dehydration takes place. H2O goes away and we get a bond between this carbon and this nitrogen. So this is called Schiff's base. Remember another name, azomethine. Another example here, again, ethanol. Here in this case, I have taken ethanamine in acidic medium, heated, dehydration will take place, C and N will get attached, we will get ethylidene ethanamine. Remember, when the ethyl group along with double bond, it is called ethylidene. Okay? And then it is ethanamine, that's why ethylidene ethanamine. Another example here, you have benzaldehyde or benzyraldehyde, and you know that the correct IUPAC name of this one is benzyraldehyde. Okay, you get it reacted with aniline. Aniline is a type of amine, okay, aromatic amine. So again the same thing happens, dehydration takes place and this CN bond will get attached. Here I will call it benzylidene aniline. This part is aniline, you know it, this is aniline. So that's why benzylidene aniline. These examples are important. These reactions are also asked, for example, this one will be missing, it will be written as this one will be missing and you will be asked complete the reaction. Okay, otherwise you must know what is Schiff's base.